Hey guys, this looks like a fun one. This is another Catriona Agg puzzle. It tells us that we have 3 squares and that the smallest has an area of 7. And it wants to know what's the total shaded area. If you want to try it on your own, pause it right now because I'm going to solve it in 3, 2, 1. First, let's label the sides of the larger square X. And let's label the sides of this smaller square Y. We can now write a formula for the shaded area. The shaded area will be equal to the large square, which is X squared, minus this square, which is y squared, minus this square, which is 7. This is what we're trying to solve for. Let's put a box around it. So to move forward, I'm going to make one assumption that isn't explicitly stated, and that is that this semicircle is intersecting this square at these corners. I don't know how I would solve it without that assumption, so I'm going to make that assumption. Comment if you have another way to solve it that doesn't use that assumption. Using that assumption, I'm going to draw the line from here to here. This is the radius of this semicircle. The semicircle has a diameter of x, which means the radius would be half of that, or x over 2. And then next, let's draw this perpendicular line. This is the same length as the side of this square. And this square has an area of 7, so the side length is square root of 7, which means this has a length of square root of 7. And last, let's connect this right here. This distance is half the side of this square, so it's going to be y over 2. Now let's play around with this right triangle. As usual, we're going to use the Pythagorean theorem, which is a squared plus b squared equals c squared. In the place of the a, we'll plug in this side right here, root 7. In the place of the b, we'll plug in this side, which is y over 2. And in the place of the c, we'll plug in this side, which is x over 2. For the first term, the square root and the square will cancel each other out. So we're left with 7. For the next term, the exponent distributes to both the top and the bottom, giving us y squared over 2 squared. And same thing over here, this changes into x squared over 2 squared. And then let's simplify this. 2 squared is equal to 4. 2 squared is equal to 4. And let's give this 7 a common denominator. 7 is going to be the same thing as 28/4. And now that these have the same denominator, we can write them as a single fraction. 28 plus y squared over 4. Next, I don't really like fractions, so let's get rid of this denominator. We can multiply both sides of the equation by 4. This 4 and this 4 will cancel each other out, and this 4 and this 4 will cancel each other out. So now we have 28 plus y squared is equal to x squared. Let's subtract y squared from both sides. On the left-hand side, these y squareds will cancel each other out, so we'll have 28. And that'll be equal to x squared minus y squared, which is x squared minus y squared. And check this out, we needed x squared minus y squared. In the place of this x squared minus y squared, we can plug in 28. 28 minus 7 is equal to 21, and there's no units in the original problem, so we'll give it a label of units squared. This is the answer to our question. It's already in a box. How exciting.